Good evening, students. Today I want to discuss the next topic. After this calorimetry, we have to discuss the transfer of heat. The heat can be transferred by the three important ways, by the three important modes. So, modes of transfer of heat are as follows. One is conduction, second is convection, third is radiation. Conduction, convection and radiation. These are the three important modes of transfer of heat. So, dear students, today I want to discuss first I want to discuss mainly regarding the process of conduction. This process. Conduction. So, let us first. These three are the modes, but let us discuss conduction. What is the conduction? In case of the conduction is the process of the heat transfer in which the heat is transferred from one part of the body to another part of the body at the lower temperature without any bodily movement of the molecules of the substance. That means, suppose it is taking place from a body at one end to the another end. Generally, or you can say it always be flowing from the body at the high temperature to the low temperature in the same body, right? And there is no bodily movement. Then what will happen? Suppose there is a conducting rod. Same metals. Generally, metals are good conductors. Suppose this is a metallic rod. If this metallic rod is heated at one end A, suppose end A, in this end A it is heated. I say it is the hot end. Let us say it is the hot end. And this is the cold end. I heat this side. Then what will happen? The heat will be transferred. Heat will be flowing like this from the hotter end to the colder end, right? But there is no bodily movement of the molecules. What is the meaning of it? That there is no bodily movement of the molecules. क्या मतलब है इसका? Bodily movement नहीं हो रहा है, इसका मतलब हुआ, मान लो इस एंड में जो फर्स्ट मॉलिक्यूल है, that is getting the heat energy. It is excited. Its kinetic energy increases. It vibrates. And this energy is given to the adjacent molecule. Its energy also increases, kinetic energy. In this way, the energy is shared just in the neighboring molecules. And in this way, molecules are at their own place. But the heat is transferred in the form of the energy from one end to the another end. Such a type of process is called conduction. So in case of the conduction, the heat is transferred from one part of the body to the another part of the body at the lower temperature without any bodily movement of molecules. Okay. Now see, this is about the conduction process. Now I want to discuss in a conduction process what is the meaning of the variable state and what is the meaning of the steady state. Try to follow. Suppose this is a rod, metallic rod of uniform cross section. I am heating it from this end. The heat will be transferred. From this end is heated and A is heated. It will be transferred to the end B. What will happen? Every portion, the temperature of every portion will rise. Try to follow. The portion which is adjacent to, which is nearer to A has the greater temperature. And as we go away from A, it has the lower temperature. But every section, suppose here, every portion, the temperatures are different and temperatures will be rising, changing. Such a stage is called the variable stage. In case of the variable stage, during the heat transfer, every portion, every cross section of the metallic conductor, okay, it is at different temperature, and the temperature will be increasing continuously as long as we are heating the rod. Now, suppose I cover this rod, like this. Here, look at this. I cover this rod by some insulating material. Here, it is covered with some insulating material. It is the insulator. I have covered this rod with the insulator or the insulating material. Then what happens? After some time, we have heated this end. After some time, we will see that every section, suppose A section है, or suppose E section है, every section, temperature of every section will become constant. It will not be varying. Suppose the temperature of this section here is T1 and this section is suppose T2. So these sections whose temperature has become constant, these cross sections are called isothermal cross section. These are called isothermal cross section or isothermal surfaces. This is one isothermal surface, this is another isothermal surface. You know what is the meaning of isothermal? Temperature constant. The surface or the cross section whose temperature is constant, that is called isothermal cross section. So, isothermal cross section, and in this case, it is called the steady state. And suppose I consider this distance is delta x. Suppose then T1 minus T2 by delta x. What is this called? This is called temperature. This is called, temperature gradient. Change in temperature per unit distance. And obviously, the cross section or the surface, isothermal surface, which is closer to the hotter end will be at the higher temperature, farther from the hotter end will be at the lower temperature. So T1 is always greater than T2. Mind this, here in this case, T1 is always greater than T2. Mind this. This we are getting. So this is regarding the steady state and the variable state. Now, a very important thing which I want to discuss about this conduction process is regarding a quantity. This quantity is called the thermal conductivity. I want to discuss now the thermal conductivity. Just try to follow this thermal conductivity. See here. Here is I want to discuss the thermal conductivity. See, I hope you all are understanding this. Here I just making this here in this way. This is, suppose this is a cube. Okay, it is a cube. This is the hot end. This is the cold end. And suppose if it is heated this side, and now it is at the steady state. Suppose the condition for the steady state has been maintained, that is whole thing is covered by the insulating material, it is at the steady state. Suppose, let us consider that this cube is at the steady state. The temperature difference, the distance between these two ends is x. Then amount of the heat conducted, I write here, amount of heat conducted. Okay, Q. It depends upon following factors. It is depending upon what? It is depending upon A. A is the cross-sectional area. A is the cross-sectional, it is directly proportional to the cross-sectional area of the surfaces between which the heat is conducted. This surface and this surface area. Directly proportional to temperature difference. Directly proportional to the time duration. You can write directly proportional to the temperature difference, also directly proportional to the time duration for which the heat is conducted, definitely, and inversely proportional to the distance between the two surfaces. Let's say that between these two surfaces, as shown in the figure, the heat is conducted. Cross-sectional area of these surfaces, each surface is A. Temperature difference, time duration, and the distance. Then what happens? Q is directly proportional to A into T1 minus T2 into small t by x. Or we can say Q is equal to capital K into A into T1 minus T2 into small t by x. Where K is called, it's a constant known as coefficient of thermal conductivity. Look, it is called, K is a constant. It's a constant quantity. For a material, it's a constant quantity, and it is known as the coefficient of thermal conductivity, or generally thermal conductivity, under simply normally thermal conductivity. Anything you can say. If the value of this thermal conductivity for a material shows the degree of conductivity of that material, the degree of conductivity. If a material is a very good conductor, its thermal conductivity will be higher. If a material is not a good conductor, bad conductor, thermal conductivity will be lower. So this is the thermal conductivity. Now you can very easily find out here its unit. Now unit of K is equal to how much? Q into x by A into T1 minus T2 into T. Okay, now put the unit. Joule meter by meter square. It is per Kelvin. It is Kelvin. It is second. Just see. Joule per second is watt. Meter, and this is, we don't slash. So what we shall get? Watt per meter per Kelvin, or watt per meter per degree Celsius. This is the SI unit. As I told you before also, that temperature difference will be the same in the Celsius scale as well as in the Kelvin scale. So we can write watt per meter per Kelvin or watt per meter per degree Celsius. This is the SI unit. And if I want to write the CGS unit, that is also very simple. CGS unit will be calorie per second per centimeter per degree Celsius. Look, this is the CGS unit. Both the units. In the next lecture, we shall define this thermal conductivity. Okay.